Hey everyone, hope you're still awake. It's a long day. So, who was last year at FOSDEM and saw my presentation on routing guidelines? Okay, a few. And who's familiar with it? Yeah. Okay. Well, so I'm asking because this talk is somewhat of a continuation of last year's that I introduced the feature. And now I would like to go through the process of designing a guideline from scratch, so to give you a better understanding of how this works. I'm Miguel, I come from Portugal. I've been working at Oracle MySQL and I still am, for 15 years now. Worked on multiple different projects, some not so successful, others more successful. I would say that the most successful ones was InnoDB Cluster, ClusterSet, ReplicaSet. But now I'm working on something in parallel, something different. There is a component in the server. I will present tomorrow, so if you're interested, please join my talk. All right, so let me give you a quick refresher on what routing guidelines are. For those familiar, it's a refresher. For those not, I hope it gives you a decent understanding of what it is and how it works. So first of all, the first question is, why did we came up with this thing called routing guidelines? And the obvious reason is that in modern architectures, it's essential to have good routing because you want to achieve performance, to scale out, to get better resilience, and to also for the routing to adapt to the changes in the architecture. So yeah, modern topologies run these conflicting workloads. Different applications will and most certainly have different routing requirements. Think about something using for OLTP, something for analytics, and different types of workloads. And static routing rules can't evolve with the topology. The topology might change. You might add new servers, remove servers, things crash, and so on. So that's the reason why we came up with routing guidelines. They are a declarative, you will understand why declarative, way to express the intent of routing, and they are evaluated by MySQL Router. That is the middleware that sits between the application clients and the topology to do the query routing and forwarding that Vittorio spoke a bit before. And these guidelines are based on rules. So they use rules to express the intention of routing. And those rules have input. So they have three different types, I will say, categories of attributes. So the ones related to the session itself, the session that comes in, the ones related to the router, and the ones related to the server. I'll show which are those attributes with some examples. And so in general, routing guidelines enable workload-aware routing. So classic read-write splitting of MySQL Router will just write traffic to the primary and read-only traffic to the secondaries or read replicas. With routing guidelines, you can do much, much more than that. So how does this work? They are composed by two main components that are destinations and routes. Destinations are, they group servers based on a rule. So those servers are grouped for a purpose. So that defines eligible targets for routing. Those are the destinations. About the routes, it's the main, it's the policies for routing. So also using rules, you can define how should a specific connection behave to according to those rules, and they use those attributes of session, router, and server. And finally, the ordering happens in the evaluation of routes. So they are evaluated top to bottom. So the first matching one from top to bottom is the one that is going to be applied. So with that, you can build a how do you say? Priority? Yeah, like that rule. So about the variables that I was speaking about, so the server ones, they are related to the server itself. Can be the version, address, the member role of the server, for example, if it's a primary, secondary, or a read replica, and many other things related to the server. The session ones related to the session that is used, the connection that is established, the username, source IP, the schema, for example, and many others. The full list is on the documentation. I'm not going to go through it now. And the ones related to the router are the characteristics of a router instance. So hostname, port, if he's using the connection is using the read-write port, the read-write split port, or the read-only port, the version, and those things. And then using functions and operators, you can build those routing rules as you wish. And starting from the logical operators, that are, I think those are the ones mostly used, so and or not. Inclusion checks. You can use the like operator, you can do arithmetic operations as well, comparisons, and use those well-known functions such as concat or check if an IP address is IPv6 and so on. Okay, so this is just an example of very simple routing guideline. And this routing guideline mimics what router does by default. So just to illustrate on top, you have the destinations. That's a list, an array. This, by the way, routing guidelines are JSON. You can build them using shell. In the admin API, we built an API to create routing guidelines very easily with commands to add instances, to add destinations, to create routes, visualize things, evaluate the routing guidelines, import guidelines, and so on. But you also can write them in JSON as you wish. So back to the JSON, the destinations in that array is defining two destinations. One is called primary, and the match is the role itself. So I'm using a member role here, server member role, and if it is primary, I will group all the servers that are primaries in that destination group. And the other one for secondaries, same rule, but using member role secondary. So in a classic InnoDB cluster of 3 members, I will have 2 on the secondary and 1 on the primary. Then in the routes, there's only one rule here. The name is RO, read only. The rule is that if the session target port is the same as the router read-only port, so the session is established to the router's read-only port, this rule will be applied, and then it will use as destinations. Those destinations are grouped by priority. So with priority 0, so if this rule is matched, and then we go to the first priority, it's the secondary class. If there are secondary members available, this is the one that is going to be used, so traffic flows there. If no secondary is available, we jump to the second destination. So primary will be used. So that's just router's basic default behavior for read-only traffic. Then there is the name, long-lived MySQL, the version 1.1, and there are other things such as the strategy, round robin by default, and and that's it. Okay, so I hope you understand what and how routing guidelines work. Now, about the scenario that I wanted to discuss today and to build a guideline for it. So the scenario is a cluster, 3-member cluster, MySQL router on top, between the application and the topology, and there are some read replicas attached to the cluster itself. So it's a basic InnoDB cluster of 6-member, 3-member group replication, and 3 read replicas. Now, this cluster is used for OLTP, very common, and not only OLTP, there will be other types of traffic in this cluster, and that type of traffic is backups, reporting, analytics. So OLTP, backups, reports, and analytics. As you know, OLTP traffic should, and everybody wants, to be fast and predictable, and the read replicas are used for the backups, analytics, and reporting, and router takes care of the routing decisions. Now, by default, router without any routing guidelines, so router's default behavior is that write traffic flows to the primary, and read-only traffic flows to secondaries, or secondaries and read replicas, or just read replicas. By default, I think router uses secondaries and read replicas in a round-robin fashion. So what happens here is that OLTP traffic, if it's writes traffic, goes to the primary, nothing to think about. If it's read-only, we'll be using any other of the secondaries or read replicas. But read-only OLTP traffic that is read-only is the same as backups. It's also read-only. Analytics is also read-only. Reporting, also read-only. So what happens is that OLTP will be competing with those different types of workloads. So this is a problem. You will introduce latency. And this basic read-write splitting alone can't express the workload intent. You cannot just differentiate between the different types of read-only traffic. So let's design this. Let's turn those requirements into a routing guideline. And like I was saying, there are some operational pressures. OLTP traffic is very latency sensitive. Analytics, reporting, and backups might be long-running, might be disruptive, and nobody wants routing logic in the applications, right? So with that, we can distinguish those 4 types of workloads: OLTP, backups, analytics, and reporting. So this is our scenario. And let me ask you a question. So what do you think OLTP traffic should compete with? So should it be nothing, just fully isolated? Or can it compete with other reads? So same instances can be used for other things? Or even could it compete with analytics and reporting? What do you think?
Ideally, fully isolated if possible.
And fully isolated means use the secondaries and the primary? That's what you mean by fully isolated?
No, I need sharing cluster.
Just a cluster? No, yeah, the same cluster, of course, but no. But here, I mean, in that cluster, so you're saying to use the primary and the secondaries, no read replicas, yeah? Is anyone awake? Vinny?
No, very true. I think with other really have
Because if secondaries are gone, for example, you want to keep it up and running, right? So use other read replicas. Is that why?
Prioritize the primary for writes only.
Yeah. Okay. Well, I think you're all sleeping, so anyway, let's. I think that it's common sense that OLTP must stay fast, so must use the primary and the secondaries. Read replicas have some latency because they are asynchronous replicas. And analytics and reporting must not interfere with it because they introduce a lot of latency. So they are bursty. They will run, for example, a backup starts running, or analytics, heavy scans, or long-running queries. They will interfere with read-only traffic, and we don't want that for our LTP. So LTP needs a dedicated path. Heavy reads, like I was saying, must be routed elsewhere. And again, read-only, that's characteristic of the session, is not enough to express the workload intent. So what we can do here, as a start, is to create a routing guideline. Here I'm defining a route, two routes, starting from top. The first one is read-write primary, so there's nothing to discuss in that sense. If traffic flows to the read-write part of router, it goes to the primary. That's it. If the primary changes, it goes to the new primary. Router is aware of that, of topology changes, and can behave and react to it. As for the read-only traffic, on the bottom, if the session target port is the router's read-only port, call it read-only default OLTP. We will use as top the first option is to use the secondaries because they won't have so much latency. So the routing rule will send all traffic to the secondaries. If no secondary is available, we want to keep the service up and running. We want to ensure that read-only traffic remains operational. So we send it to the second priority, that is any RR, that's any read replica. So this is a basic start for a routing rule. And I already mentioned primary, secondary, and any read replica. So we need to start defining destinations. So what do we need? We need to separate OLTP, backups, analytics, and reporting. We must avoid hard coding of things, such as IP addresses, host names, and so on, because they change. So we define the destinations based on server attributes, nothing else. So that can be reused across multiple routes. And as a start, like I was saying, we can define the primary. So the common attribute here is server member role. So I'm using primary, secondary, read replica, and defining those 3 types of destinations. But what about backup, analytics, and reporting? So that comes after, because just using member role is not enough for that, because those 3 are read replicas. So it's not enough. So for that, in this example, I just used a different attribute, a different variable. So the first one, backup RR, so it's the read replicas for backup. I'm saying that they are, member role is a read replica, and I'm joining that with something that it's called tag. Tags are key value pairs of anything. You can define them as you wish, just strings. And in this case, I'm tagging servers with a tag called the key is workload, and the first one is backup. So if any server that is tagged with that will be matching that rule, and will be put together in this group called backup read replicas. And then I do the same for analytics and reporting. It's just an example. You could use any other thing. For example, server version. You are using a specific version of MySQL for analytics, let's say. You could do that and define the destinations like that. So with this, we have the 6 destinations: primary, any secondary, any read replica, backup read replicas, analytics read replicas, and reporting read replicas. Next, again, all traffic is just connections. Read only and read write is not enough. And analytics, reporting, and backups, they all look like reads. So we need more information to distinguish those from the classic normal read traffic. So that must not come from server roles. They are read replicas, and not from hard-coded ports for sure. So in this case, as an example, you can see there the match for, I call it the read-only analytics strict. So it's traffic that should flow for the analytics read replicas, and I'm using alongside the target port being the router read-only port. I'm saying that if the schema used is a schema called analytics, then I will use only those read replicas. Could be something else, but I'm using just this. I think it's easier to understand like this, a schema. So with this, I define this routing rule called analytics strict. Okay, so what if those analytics read replicas crash, all of them, they're all gone? What's the fallback here? What should we do? Fail fast? No fallback? Should we fall back to other read replicas? Or even fall back to secondaries? What do you think should be a good decision?
It depends.
It depends, that's the best answer. I mean, do many things, right? But if we have no fallback, then we lose analytics.
So the question is, how long can we afford to lose analytics?
That's also a question.
Yes.
It depends, right? Maybe if you want analytics to be running all the time, no matter what, you will maybe fall back to other read replicas. So you don't impact OLTP traffic going to the secondaries. It's a possibility. So we can do something that is to trigger a routing rule using something live. I call it control degradation here. And this is explicit opt-in, so it's an option that you set. In this case, I'm triggering it with a connection attribute. Connection attributes are also key value pairs. They are set by the connector or the clients. And I define this rule that it's a longer matching rule, and as a start, again, read-only traffic going to the router's read-only port. In this case, I'm grouping together analytics and reporting, again using a schema. So if the schema is analytics or reporting, and if the session connection attribute, I call the key degraded OK, and if it's set to 1, this rule will be matched, and then traffic flows on top, first to analytics with replicas, and to reporting with replicas. If those are not available, then we fall back to any with replica. If none of those is available, we fall back to any secondaries. So it's a trade-off. We have this trade-off of availability of those services with predictability of OLTP. That can be a bit effective. So putting it all together as a summary, this is YAML made up by me. It's not, because the routing rules are JSON and it was impossible to put JSON here. It was large. But I added it to this example to my GitHub. I created this MySQL Routing Guidelines examples. It's there. Yeah, maybe I will add more in the future, or if you want to contribute, please, that'll be awesome. And so this conceptual representation is just to say that the guideline that we built has 4 destinations: primary, secondary, any with replica, backup with replicas, analytics, and reporting. We define those destinations. And as for routes, like I said in the beginning, they are evaluated in an orderly fashion, so top-bottom. So the first one, read-write primary traffic, flows to the primary, nothing to discuss. The second one, the backup traffic. So if is traffic flowing to the router's read-only port and using the schema backup, I will use the backup with replicas and fall back to other with replicas or secondaries to ensure that backups never fail. And then we define this analytics reporting degraded. Long name. So this is the one we just talked about. If this connection attribute is set, we enter this degraded state, and we ensure that that traffic is always up and running. And we use that order of fallback, so starting with the read replicas for the purpose and falling back to other read replicas and secondaries in the last case. Then the analytics strict, that is this one was not on the slides, it's part of the full guide. But what happens in this one is that read-only traffic using the schema analytics and the connection attribute degraded is not set. We'll strictly use analytics with replicas. And the same for reporting, and at the end of all of that, if none of those rules are matched, all the remaining read-only traffic, we know that is OLTP. So we call it the default OLTP that flows to secondaries as priority and falls back to read replicas if no secondary is available. Okay, to summarize, 5 minutes? To summarize what routing guidelines are and are not. They are a declarative routing policy, as you saw. They are not SQL optimizer, for obvious reasons. They are evaluated per session, okay, not per query. We thought about adding per query. I think we talked about it last year, Alex, right? About the per query routing. It's on the possible roadmap. I cannot promise anything. They express intent, not the topology, so they are not application logic. They are centralized and external to applications. They live in the metadata schema that is managed by MySQL Shell, and the router consumes it. Like I said, you can use the admin API commands to build and manage routing guidelines, or you can write JSON and import it into the metadata schema. They are not a replacement for schema design. They are dynamic and topology aware. MySQL router by itself is topology aware. And they are way more than just the classic read-write schema. And that's it. Yes.